Okay, thank you for joining. This is part 2 of the test review for test 2A. And this part will be working on tables, and we will be working on problems 10 all the way through problem 18. So problems 10 through 18. So a group of first grade students were asked to name their favorite color. All right. And so when I look at this table, and we have red at 15, blue at 30, green at 8, yellow at 12, purple at 25, whenever they give me a table and it's a frequency, not a relative frequency, but if it's a frequency table, I always come back and try to find my total. So real quickly, just taking my calculator right here, I'm just gonna take a moment and add these up. So 15 plus 30 plus 8 plus 12 plus 25. So I end up getting a total value of 90. I just make that a good practice every time I do this. So which of the following statements is supported by the frequency table? More students chose purple than any other color. Well, how many chose purple? 25, but someone chose that, so that's wrong. Twice as many chose blue as red. Well, how many chose blue? 30, 15. You know what? 15 times 2 is 30, so this is true. I like B for my answer choice. Okay. So the following data were collected from a sample of people on their favorite types of leisure activity and their age. The results are shown in the two-way table below. Notice they did total these up. So we have column totals right here, and we have our row totals out here. And just as a reminder, the values listed here are your joint totals, and the values on the outside are the marginals, with the exception for this one, which is the total sample, or the table total, as some people like to call it. So it says, what proportion of people aged 13 to 18 gave watching TV as their favorite type of leisure activity? So what they're saying is, we want to focus only on the 13 to 18-year-olds. So I'm only focusing on this group. This is, and I know this says what proportion of the people. So the proportion of those. So they're telling me they're given 13 to 18. So this is going to be my denominator. And we know that out in that, I'll scoot this up just a little bit so you can see it, 13 to 18, we know that there's 1,300 of them in that age group. Gave watching television as their favorite type of leisure. So now we want to know, they chose TV. Of the 1,300, what chose TV? All right, so we're looking for TV, the intersection right here. And I'm just going to write the word intersection. And the reason I write that word, and I'm going to show you in just a moment, is we said television, that's this. And look, I have a cross. I have a two-way street crossing. And where that two-way street crossing is my intersection. So basically, 100 out of 1,300. I like C for my answer for that problem. Moving over to number 12. A sample of 942 homeowners were classified in the two-way frequency table below by the number of credit cards they have and the number of years they have owned their current homes. Of the homeowners in the sample, so looking at the specific group who have 4 or more credit cards. So we're looking at this group. Is given and of our denominator words. So we know that we want 4 or more here. And that is 212, because given and of are denominator. Please do not forget that. Those are denominator words. What proportion have owned their current home for less than 1 year? So I need to go to the less than 1 year column. And remember, it's always the intersection up top. So the intersection's up top. And look, my two streets crossed at 134. So 134 over 212. I like B for my answer on this one. The following relative frequency table shows reasons given by high school students for their last absence from school. Which of the following statements is not supported by the relative frequency table? Once again, they have the word not. Whenever they do that, I'm going to be looking at the true-false technique. So more than half of the students were absent because of illness. And I look at it and go, yep, 57%. 57% were absent because of illness. This looks like this is true. More than 1/3 of the students were absent because of oversleeping. Ooh, this is tricky. Were absent because of oversleeping or college visits. This is really tricky. Or means add. So 20% overslept, 16% college. So this adds up to 0.36. And it's like, yeah, they said more than 1/3. 1/3 is 0.333. That's bigger than 1/3. So this is also true. The reason given the least number of times was not finish an assignment. Maybe. And since it was from the same group, we can say that that's true as well, because that is the least percentage. And since it's from the same sample, whether we had a sample of 1,000, if we had a sample of 1,000, then we have 570, 200, 160, and we have 7. So basically, this is going to be true because it's all from the same sample. Only 7 students were absent, ooh, because they did not finish the assignment. For 7 students to be absent, this number would be, the sample would have to be 100. Do we know the sample size? No. The sample size could have been 50. The sample size, we don't know what the sample size was, so this isn't necessarily true. So this is a false statement. Finally, less than 1/4 of the students were absent because of the overslept. And we know 20%, so that's true. So my best answer is D. And I want to go back to that real quickly. Here's how I said only 7. So if I went 0.07 times 100, that equals 7. All right, but that's if I had an N or a sample size equal to 100. What if my sample size had been 200? Then it's 14. So any number different than 100 would give me a different answer, and we don't know the sample size here. We don't know the sample size, so we can't say only 7. So it's not supported. In other words, could it have happened? Yeah, but we don't know, so it's not proved by the table. All right, so questions 14 through 17 refer to the following study. 500 people used a home test for HIV, then all underwent more conclusive hospital testing. The accuracy of the home test was evidenced in the following table. And I look at this and it's missing some information. Always, always, always total things up. And so I'm going to take a moment and do that. So when I do that, 35 and 25, gosh, I sure hope that adds up to 60. This adds up to 440. This adds up to 40. This adds up to 460. And the total is 500. All right. So what is the predictive value of the test? And that scares me. I don't know medical terminology. I don't know that word. But I can read on. What is the probability that a person has HIV and tests positive. And is an important word. It's an intersection word. Okay, I can't spell. It's an intersection word. Still can't spell. So that means I'm looking for the place, that number where the two things cross, right? It's the intersection. It's a street intersection where the two things cross. So what's the probability a person has HIV? All right, so let's look at has HIV. This group has HIV and they want test positive. So we know that we're dealing with 35. The question here is, what's the denominator? Do they tell us from what group? Do they use the word of, no given? We just have a randomly selected person. Since there's no of and no given, it's out of the total, which is 500. So we have 35 out of 500. Go to my calculator real quickly. 35 divided by 500, and that equals 0.07. I like A for this answer. All right. Okay, so pause with me for just one moment, because I've misplaced a piece of paper that I prepared for this to help these problems out. There we go, got it. So what is the false positive rate? Again, I don't know the medical terminology, but they say that is what is the probability of testing positive given that the person does not have HIV. Once again, given. That's a denominator word. All right, so we always start with our givens. They're in the denominator. So given that the person does not have HIV. All right, so no HIVs in the denominator. So let's look at that column. That's where we're starting. And we have does not have HIV. We find out that that value is 460. All right, so now for the numerator, I'm going to be looking for an intersection. All right. Was it probably testing positive given? And so the intersection is testing positive. So this is the other variable of interest. The intersection is always in the numerator. So we end up with 25 because we intersected right here. So 25 out of 460. And we end up with 0.054. I'm liking A for this answer. All right, moving on. What is the sensitivity of a test? That is, what is the probability of testing positive? Here's that keyword given, denominator word, that the person has HIV. Given they have HIV, so has HIV. So I'm going to use my little chart here. Has HIV is right here. Okay, so my denominator is, there's 40 of them that have HIV. What is the probability of testing positive? Please remember, intersection is always going to be in the numerator. So my intersection where the two cross is at 35. So about 35 over 40, going to the calculator, is 0.875. Excuse me, don't know if you can see that. All right, 35 divided by 40 is 0.875. I'm liking E for this answer. All right, on number 17. What is the specificity of the test? That is, what is the probability of testing negative given that the person does not have HIV? So given, that's my denominator word, does not. So we're going to look at our little table here. Does not have HIV. Well, that looks like 460 don't have HIV. We know we're going to have an intersection in the numerator because anytime it's a given or of is also the other denominator word. Anytime it's a given or an of, we're going to have an intersection in the numerator. What is the specificity of the test? That is, what's the probability testing negative given that the person does not have HIV? So now we're looking at negative. It's like, oh, my intersection where they cross is at 435. And we end up with 0.945. My answer that's closest is E. There we go. All right. Please remember on these problems that of and given are your denominator words. All right. Moving on to question 18, which is the last one for this video. The following table shows data collected from a random sample of 2,500 people who recently went on vacation who indicated their favorite part of their vacation. Based on the table, what proportion of, here's that of word, of the people selected gave a response other than shopping? Ooh, of the people. They didn't say which people. So we know that we're dealing with the entire population here. So this means that we're working with a table total. So we're working with 2,500 because if they said of the teens, then we have to look at the teen row, or of adults. But they didn't say that. They said of the people, so it's out of everybody. Gave a response other than shopping. So that means we're not looking at that, but we are looking at shows, dining, and activities, so we need these values. So my numerator is going to be 730 plus 475 plus 720. If I use the calculator real quickly, and we end up getting 1925, so I like C for that part of the problem.